go down. Yeah, so understanding the Hive data models, it will help us to start thinking about Hive as a any basic RDB base. And then when we talk about these things, we can see okay how it differs from a basic structured data or RDB based storage. So I have not written anything against databases because it holds the same significance here also. Tables hold the same significance here also. There is a concept called partitions in Hive, which basically means that you can any table can be split into many number of partitions, and you split it by a partition key. Basically, that key can be filled in the table column in the table. So partitions, basically, the beauty of partitions is that this allow you to store data. But as we saw earlier, the data for a particular partition is stored in a subdirectory under the table directory. How it helps is, if you are storing, say, a partition for, so like let's look at this example. Suppose a date partition of the type string and country partition of type string. Suppose we create a table with these two partitions. So what it does is each unique value of the partition defines partition. So all data with respect to, say, India and a certain date is basically a partition of suppose the table is called page views. So now if you have to do any analysis or any querying or any data crunching on that particular data, you're just looking at that subset. So you're just looking at that relevant partition. You're not looking at the entire data. So this is a scheme to basically make your processing faster and analysis, speeding up your analysis. So yeah, I hope this example is illustrative of what a partition is. Now another angle to this is that every partition can also, which is another degree or another level of partitioning, which is data in each partition can in turn be divided into buckets. So and that can be based on, that generally is based on the value of a hash function of some column. So example, let's not bother about definitions. Suppose the same page views table, I have a country partition and I have a partition. Let's look at, say, I'm looking at India's 2013, 21st May 2013's data. That data can be bucketed with user ID, and then you understand, okay, this data is coming from this user ID or it belongs to this user ID. So it further helps you to basically speed up your analysis and sampling of data. So this is how data is. This is how basically it's different from how you store data in our system. So we have databases, tables, partitions, and buckets broadly. So like, let's spend some time on the command line and try to see what we can do with Hive. So we are already into the Hive shell. This basically lets you set all any property which is basically any Hadoop configuration or Hive configuration predefined properties. So we'll not bother too much about it. We'll just run this and see. This basically lists all the properties and their values. So we'll go and just say set -v, and this basically lists a lot of values that we have, like whatever system.user, country, US, and all that. So these are all the Hadoop and Hive properties combined to fine. Sorry, trying to do that. So let's see let's run a few commands. Let's try to run show tables. So this is exactly the same as how we do it in SQL. So say show tables. So there is, I guess, no tables in Hive, so there is nothing. This will tackle later when we create tables. Sorry. So let's create a table on the next slide, and we'll come back to this describe and describe extended. So I'll just copy this here for the create table site. I'll have to remove a few things. So now we have created this table. So understand what we have tried, what we have done. We have created a table with the name site, and there's two columns, one citing and one cited. So this basically why we are doing this is because I was referring to one of the examples, and they already have a data, big enough data for patents, citing and their cited basically data. So I have this data in a text file that I load into this table elsewhere on my system here. So we can have a look at the data, although it's long, it's huge, so opening it Vim will take some time, but we can have a look. And it stores basically citing data and cited data. Row format delimited and fields terminated by, let's have a look at this. So basically the second and the third line tells us, when we're telling stored as text file, so the other option is to store as a sequence file, which is a binary format. We may choose to store it as a text file. So this is trying to tell the data in this table, you store it as a text file, and all rows that you create, all the fields will be terminated. For each field in a row, the fields will be terminated by a comma. You can specify a tab or something else here. You can specify any other delimiter also. Now, this is a small and a basic example, but a full-blooded example could be you are specifying how does each row boundary change. You can also specify row format, row delimited by a row format delimited terminated by say new line, and then fields terminated by comma. So that would have made like a slightly bigger example basically. Here we are trying to say all the fields are terminated by this thing, and the rows will be terminated by the default character M for not sure what is the default. There is a default for row delimited, so it will take the default. So we have created a table. Let's do show tables again. We'll see here. So we have a site table here with the two columns. Now let's try to load the data I was talking about. So that data is somewhere in my system, and this is the name of the file. So this is a patent data which is available on the net basically. So I'm not trying to create it. It's ready to use and good for demonstration basically. So let me see where that data is. Yeah, so it's here. So what I'll do is I'll copy this here. I'll try to run this basically. So let me execute it and then we can talk about this this command. This looks good. Okay. So before executing it, we are saying load data local bin file. So those are familiar with any RDBMS you can take a flat file or a text delimited file and load it into a table. Basically, we will say load data in file or something on MySQL. Here we are saying load data local in paths, because if you say load data in paths, then it will look for this file in the HDFS path, in the HDFS file structure or the HDFS directories. Because it's not on HDFS, it's on my local machine, I have to give load data local in path. I give the file name, a path to the full file with the file name, and then I say overwrite into table site. So when I say overwrite, it means it will overwrite the data, sites data with it. If I don't say overwrite, it will append the data. So this is one thing, another unique thing about Hive. We have a freshly created table, so we better go with the overwrite thing, and we'll just execute this. So here is something. Okay. So I think the problem is this. Give me 1 second. So it's trying to copy this file into the table. Because it's kind of big data, it will take some time. So our data is loaded into the table. So now we can do something like select star from, like we do in SQL. So let's say we execute this. So we can see, I think the first nulls are because the first two fields are not integers. So as I said, when we load data, it is not on write, it is on read. So when the query runs, it finds out, oh, these two columns are basically, not integer types, because the site is defined to hold only integers. And the first two fields have the names of the columns in the file. So let's have a look at the file as well. I think we are running a bit short of time because you have to cover HBase also. So I'll proceed a bit faster. So we can see 10 pieces of data from this table. Other thing we can do is we can do something like, the total count of it. So there is, basically it is nothing but the count star in MySQL, so SQL. There's a syntax difference, we say count of 1 from site, so we run this. Copy paste here. So you can see here, one thing that we can observe is when we run this, because it's a count, and for count you have to aggregate data. It's running MapReduce eternally, so it's firing a MapReduce job here, and it is basically in turn that MapReduce is basically going to compute the count. So we'll let it go. I will have a look at the console. So this basically is showing the progress of the map and reduce jobs. You can see like the map phase is over. Once the map phase is over, the reduce starts, and then the reduce is over. And so basically, this is your answer. This is your count, and all that. So now what I'll do is I'll skip this part because you already spent. You are eating into the HBase time. What this does is this creates another table called site count, which is nothing special, which we are trying to store the counts of each siting. And what we are doing here is we are running this command here, which basically inserts, which runs this command first, which is select cited and then count of citing from the previous table that we've just populated, groups it by cited. So don't get confused between cited and citing. Just consider them two columns that are associated with each other, and we are grouping grouping the data on one of them, trying to find the count on one of the columns. And then we have the result of this query is nothing but basically a data set which can be stored into a table. So we are storing it into another table called site count, which stores the frequency, the count of cited and the count. Because both the things we are returning here are integer, it will fit nicely into this, right? And then when we run it, we query the count table, we do a select star for count. I think let's do it. It's not. Let's do it. So I create another table. If I do show tables, now I have two tables called site count and site. Now I do this. This is just to show how a group by runs. Group by also basically internally will fire a map reduce. And we are taking data from one table, querying it and writing it into another table. So this is normally the practice in Hive because you normally want to take data from one, take a snapshot of it and store it into a different table and then do your analysis on that table and partition and all that. So we say insert override table. So this also fires another map reduce, and it starts map reduce job. Let's wait for it. Other than that, till it covers basically, you can just query this table and see the counts for the top 10 or some 10 records. As in SQL, we can drop a table by doing drop table, so we'll just drop this table, and that's it. We'll just see where we are. Since it's a group by on a big table, this is going to take some time. So we'll come back to this. As I was talking about the partition data, partitions are nothing but basically shards or sections of data with respect to a certain column or more than one columns, which are stored as subdirectories in the table's root directory. So let's take an example. Let's say we have something like a create table 1 on two fields, ID and message, and we are partitioning it by something called as a date, which is there in the data that we are partitioning by. Now, when we create this partition, what it does is it will create a subdirectory for each date, basically. So it creates a subdirectory for each value of the partition column. So if my partition column is a date, for each date there will be a directory created, and so needless to say, what it does is I can just, if I have to do some analysis on only that particular date's data, I just can